Today, in this video, we'll be building a smart contract with Foundry, and we'll build it and deploy it to our local blockchain. And then we'll deploy it to the Ethereum blockchain as well on the Goerli testnet. Okay, so it's going to be very, very helpful in case you want to know how to deploy to the main blockchain. So deploying to Goerli testnet is very similar to deploying on the blockchain, the main net. The only thing is you won't spend real actual money while deploying it. So it's just a safe way to test how deployments work. So so we'll be going through the complete life cycle, right from starting a new project in Foundry to writing a smart contract to building it, testing it, deploying it to the local blockchain, and then deploying it to Goerli. All right. Now, there are a few things that you need to be able to deploy to Goerli testnet. First thing is you need these testnets to be enabled. So you'll have to go to settings and enable these testnets in your MetaMask. So you need your MetaMask account, and then you need to select Goerli test network, right? And you need to see how much Goerli do you have right now. So I have some Goerli ETH, but maybe you have 0. That's all right. We'll fix that. You need to copy your account and keep it safe. So like put it in a notepad or something like that. Keep your account details here, and then you need your private key. So you can go to account details and get your export to private key. All right. So I'll do that later on. The reason is because you want, when you deploy to the Goerli testnet, you need the contract to be associated to an address, which is your account address, and you need to sign it with a private key, which is the private key that you export from here, right? So you need these two things from MetaMask, and also need to enable Goerli testnet. You need to select that. You check how much Goerli ETH you have. All right. Second thing is you need the Etherscan API key. So you create an account in Etherscan. Once you log in, you'll see something like this. You go to API keys and create. When you click on add, you create a new API key, and this is my API key for my Foundry app, which I'm building today. The other thing you need to be able to deploy, right? You need to be able to deploy the smart contract to the Goerli testnet, right? Now, to do that, you need a node. So in the olden times, like 1 to 2 years back or whatever, you had to start your own node, your own Ethereum node locally, like with Geth or something like that, and then you had to connect to the main or the testnet, whatever, and you had to deploy your smart contract with the help of apps like Alchemy and Infura. These are something called as super nodes. What they've done is they've created a node, but the node is not just a Geth node. It's not just limited to Ethereum, right? The node is connected to so many other blockchains as well. So once you have an Alchemy or an Infura API key, with the help of that, you can deploy to multiple different blockchains. So just to show you an example, I've already created this demo app, this Foundry app. So when you log in to Alchemy, when you create an account, you get like a demo app in your own app. These ones you don't need. You need to create an account, an app like this, like the Foundry app that I've created. And I'll show you how to do a new app. So you'll write something like this, test or something like that. And you can select the chain that you want to deploy on. So I'm going to select the network. So in our case, it's Ethereum, and in our case, it's Goerli. And then you can create the app. In my case, I've already created the app. It's called Foundry. And I can just view the key. What you need is the HTTPS key, right? This is the API key, but you need the HTTPS link because you need from your local CLI, you want to connect to the HTTPS Alchemy, and using your API key, it will then connect with the node, the Alchemy node, which is then connected to the blockchains, and will deploy from there. So you don't have to start off your own node to do this, right? So that's awesome. Copy your HTTPS and keep it somewhere safe. Now, one thing I showed you was that your Goerli ETH, you might not have these, so you want to get that. Now there's this website called goerlifaucet.com. I highly recommend this website. This is powered by Alchemy, and if you have an Alchemy account, you can just log into this directly, right? So you don't have to create another account, and you just put your wallet address here and send me some ETH, and it'll send you some Goerli ETH, okay? And then you'll be able to see something like this when you have some Goerli ETH, and then you'll be able to deploy your smart contracts very easily without spending actual money to Goerli testnet. Right, so these are the few things that you need before you get started. And obviously you need Rust installed, you obviously need Foundry installed. And there was a video that I've just built, like the video previous to this. I've shown you how to work with Foundry, right? How to work with Foundry and Anvil, all of that. Anvil is the the blockchain that you get, and you also work with Cast, which helps you to interact with the smart contract. So I've shown you all of that, all right. And this video also will be part of the 50 Rust project series, because this Foundry is built with Rust. And I've already done like a Foundry video before. That's like an introduction, but this is like, we're getting hands-on, like serious. We're building a smart contract and deploying it to Goerli testnet. So it's like serious stuff right now. All right, so what we'll do is we'll get started. Okay, so you have these things, everything is ready. You've copied your API key from Alchemy, you've copied your account from here, copied your private key, all of that. You already have all of that. You also have your Etherscan API key, right? So keep all these things handy. We'll need these. And so let's get started. Now, before we start building, I just want to give a big shout out to my intern, Nikhil, because there's a lot of work that goes into building these projects before we even start shooting. So we have to ideate, research, build the projects, test them, check them out, create documentation, and then we start shooting these projects. And that takes a lot of work before we even start shooting the video. And all of these technologies are still so new that sometimes the documentation is not proper. You get errors which nobody has solved before. So I need a lot of help, right? So, and Nikhil is my intern who helps me a lot with all this. Thanks a lot, Nikhil. Thanks a lot for your support. And so let's now start building. So I'm going to go ahead and start off a new project here. So I'm going to say forge init Foundry Goerli YT for YouTube. I'm building it with you guys. So it takes a while and it builds the project for me. So I'm going to cd into it, Foundry Goerli, and I'll open this up in the code editor. And we get our familiar project. Now, this is something that we will now change around, okay? The smart contract is what we'll write from scratch. And then we'll also write some tests here, right? For test files, you can just copy and paste from my GitHub. I'll paste this project on GitHub. I've not put it yet, but I will do that soon. And then you can pick it up from my GitHub, okay? And I'll leave the link in the description. And I'm Akhil Sharma 90. So in case I don't leave the link, the project will definitely be there on GitHub. So you can just go to Akhil Sharma 90, which is my profile name on GitHub, and get it from there, right? So the test files you'll be able to. So I'll write a complete test file, and you can get it from there. The smart contract, we'll write it together. All right. So what I'll do is I'll just get rid of this quickly. And here I'll start off a new contract called crowdfunding. So we'll have a proper crowdfunding contract. We'll have a campaign. The campaign has address. It has a which I'm going to call as owner. Okay. And it has something called as title, which is going to be a string. Then it's going to have a description, and a target, Then you'll have a deadline, an amount collected, image, and donators, and donations. Okay. We'll just give the types of all these. So description string, target is uint 256, deadline will be again uint 256, amount collected uint 256 again, and image will be string because it will be a URL mostly, and a collection of these addresses will be the donators, right? All the addresses of all the people who have donated will be the donators, and donations will be a list of uint 256, right? How much donations they've given. So there's a small typo here. So this is our small struct for our Solidity smart contract. Then we'll have a mapping uint 256 Now, if you're somebody who's not interested in Solidity at all, right? And I know there could be many people, and you just want to learn Foundry and how to deploy using Foundry, that's completely all right. You can just skip this complete part and just copy and paste this entire counter from my file, from my project. That's completely all right. But some of you are interested in learning in Solidity as well, and you want to go through the entire contract with me. That's why I'm taking you through it. But you can skip in case you're not interested in Solidity. Completely okay. You can completely skip it. Okay. So uint 256 public, and we'll have number of campaigns. We'll start with 0. Then, like one of our important functions here will be to create the campaign in the first place, right? So we'll have a create campaign function, okay, and that will help you first initialize all these things. So you'll have address and string, memory, title for description, all of that stuff. So let's do that. So the create campaign function takes in quite a few parameters, okay, and then it initializes them to create the campaign based on the struct. Okay. Now I'm assuming obviously that you know Solidity already. In case you don't know Solidity and you're still watching this, then I do have a series on Solidity, but I couldn't like create a lot of videos in it. It just has 3 videos. I wanted to create more videos in that series, but I just couldn't find the time. But I plan on creating more videos there. So just be on the lookout in case you want to learn Solidity in more detail. Anyhow, so here it accepts some parameters, and what I'm going to say is it's going to accept basically all of these things: address and description, target, deadline, all of these things, and also the image. It's going to accept the image. Okay. Only thing is you don't need these here. You actually need commas. And you also need to change them slightly with a underscore. And here's string, say memory, then you have target, deadline, memory, image. Okay, this function is public, returns a uint 256. And now we can start building this function. Okay, so firstly you'll have your campaign, which is storage. So there's a difference between storage and memory. In case you don't know about this, you can there are a lot of articles on Medium. I won't get into that. It's a big topic, right? And I'm assuming if you know Solidity, I'm assuming that you already know this. But if you don't, there's so much content out there about storage and memory. So what we require is campaign dot deadline should be less than block dot timestamp, and say the deadline should be a date in the future. It can't be a date in the past, it can be current time also. Okay, so that's your required. And now you just want to go ahead and initialize campaign. So let's say campaign dot owner is equal to underscore code, right? So when you are creating a new campaign, you want to go through this campaign object based on the struct. You want to create that and you want to initialize that with the values that this function is receiving. So if campaign owner is equal to owner, which you just received here, and similarly you'll have campaign dot title, and I'll just copy and paste this quickly actually. So you have campaign dot title, which is underscore title, and then you have campaign dot description underscore description. You have campaign dot target, deadline, and amount, control, and image. So I'll say target, deadline, amount collected in the campaign, and the image. So this is equal to underscore image. To begin with, it will be 0. Deadline is underscore deadline, and target is underscore target. Okay, so we have all of that. Here the spelling is wrong. Now I think issues would go away. Okay, and what we'll say is, we'll say number of campaigns plus plus, and return number of campaigns minus 1. Then you'll have a function to donate to campaigns. So just mind you, this is all inside the crowdfunding contract. Okay, so we'll have a function to donate to campaign. So we'll say function donate to campaign, and we'll take an uint 256 and the ID of the campaign. Public variable. Then we have function for withdrawing from the campaign. Function withdraw from the campaign uint. Uint 256. Okay, so when you want to donate to campaign, there'll be a payable function because you actually pay the function. When you want to withdraw, you can just withdraw it. Okay, and finally, after this, we'll have a function to get the details of the campaign. So we'll have uint 256 ID. Okay. Well, it's a public function, view returns, and it returns a couple of things. So we'll define that. Returns address, returns string memory, return string memory again, and uint 256. Right, so all the data of the campaign. So we know that the campaign has all these things, right? Address, string, uint, and these 3 uint 256 here. So I'll just copy and paste them 3 times. And then you have again string memory. Okay. So let's quickly complete these functions. But here in the get campaign function, this is the easiest one. So I'll just complete it quickly. In the function definition, you can just say campaign memory campaign is equal to campaigns ID, and you'll return the campaign. So you'll return the various different things, like various different values, like for example campaign owner, campaign title, campaign description, all of that. So I'll just copy and paste these, all of these here. Now let's keep putting commas after all of these. Sorry. Okay, so get campaign takes in the ID of the campaign and returns all the details of the campaign. So for example, the campaign's owner, title, description, target, and so on. Okay. Now the 2 functions that are left are donate to campaign. So how do you donate to campaign? You will have uint 256 amount that you're going to send to the campaign, which will be part of the message.value. Then you have your campaign struct storage and your variable called campaign is equal to campaigns underscore ID being the one that you passed here. So from the campaigns collection, you'll find the campaign that you want, and campaign.donators.push. So the person who's sending the donation, his address will be be stored in the list of donators, and his donation, also the amount of donation he's sending, also needs to be pushed. Okay, and this is doing the same amount as message.value. Then you'll say campaign.collect amount collected equal to campaign.amount collected plus the amount. So amount collected is the amount that it already had, and we'll just add in the message value, the amount that we just received. So you updated the donators, donations, and the amount collected for the campaign. Now in the withdraw function, we'll say campaign storage campaign equal to campaigns underscore ID require campaign.owner should be message.sender. Right, so only if you can only withdraw if the campaign owner is equal to message.sender, and we'll say only the owner of the campaign can withdraw the funds. Right, the guy who starts the campaign saying that I need to raise money for this thing, and then the crowd, they fund it. So only the owner obviously can extract all the value from the fund. And you have a couple more required conditions. So I'll just copy and paste those here quickly. So the thing you want to check is that the campaign amount collected should be more than equal to target. If you haven't met the target, you ideally won't want to extract all the value. Also the money should be extractable after the deadline has passed. So we'll be checking for those two things as well. And then comes the withdrawing part, which is with this. You withdraw, right? So you use the call method, and you campaign owner, and you get the amount collected, right? True or false. And then the money is sent. Then you said campaign amount collected is equal to 0. That means all the money, if it was sent to the campaign owner, then you set the amount collected to 0 again, because all the money has been extracted from the smart contract. All right, so this is what our smart contract is. It's a very, very small, short smart contract, just about 100 lines. And it's quite possible that we may be missing something. So I'll just go through it very quickly. Crowdfunding campaign. So we have the create campaign function, and then we have our donate to campaign function. All right. And we have our withdraw function. Makes sense. And our get campaign function. Everything looks okay to me right now. Even if there's some issue, we can fix it later on. And now what I'll do is I'll just copy and paste the test file here. So I'll rename this. I'll say crowdfunding.t.sold. Okay. And what I will do is I will copy and paste this test file here completely. And you'll get some issues. That's because you'll have to again run the remapping command. So in the previous previous video for Foundry, we'd seen that after we change the smart contract and the test files and all that, we have to create a remappings.txt file. So we'll go here, we'll say remappings.txt file, and we'll have to run a command. We'll have to run a command for remapping, right? So I don't remember the command, so I'll have to look for it, guys. The command is called forge remappings. So I'll go here, I'll say forge remappings. So I'll get these two lines, and I will go ahead and copy and paste them here. And that should make the issue go away. So you have no issues in the test file, you have no issues in the Solidity file. And now to check if everything works all right and the test file works all right, we can test it. So we'll say here forge test. So all the test cases are passing, which is awesome. This is what we wanted. And if you want a little more details, for example, if you say I want forge test minus gas report, you can get that. I can get like a gas report for all the functions while testing, and then I can get a little bit more details. So I can say forge test minus VV, more details, right? You get just a little more details in the logs. And if you want even more details, you can say V 4 times and you get complete logs, right, while testing. So these are good commands to know, like forge test minus VV, forge test minus VV, and forge test gas report. These are just nice commands to know when you're working with Foundry. Then we want to deploy to Anvil. So to deploy to Anvil, what we'll do is we'll start off Anvil here. So we'll say Anvil is our local blockchain, right? So it's starting now, it's running on 8545. You need to keep it running to be able to work with it. So here, what I will do is I will first export my private key, just like we did in the previous video. Now, yeah, so one more thing I want to tell you is you can go to scripts, right? And you can update the script here. So let me show you how to do that. Okay, so you can update the script here. Okay, this is your deployment script, and you can set your private key in a config file, environment config file, and then that private key will be pulled here, and then you'll be able to deploy to Anvil, and then you can change that private key to be able to deploy to, let's say, the Goerli network or the Ethereum mainnet, right? But I won't do that. I'll leave this script with you guys, and you can use it if you want to take it to production. But right now, let's assume you're just playing around in your terminal, not sending it to production, right? So for that, you would need to set the your what do you call it, private key in the terminal itself as an environment variable. So how would you do that? So what you'll do is you'll say export private underscore key equal to one of these private keys I'll take. So let's take the 0th one. Copy, paste. Okay, so I've set my environment variable. Now I can set that, like I said, showed you in the config environment variable file also, and my program will pick it up. But let's say you didn't do that, you forgot to do that, or you had some confusion around it. I'm just showing you a way that you can set all these environment variables in the terminal itself, in the terminal where you're running your program, right? Or you could have all of these in the, like I showed you, in the config env file. And to be able to run that smart contract, to be able to and now we'll go ahead and deploy it. So to deploy it to Anvil, so here it is, forge script slash crowdfunding .s.sol. This will use the script from the crowdfunding one, the script which should have like the private key. But let's say you forgot the private key, still it will work. So minus fork URL, and it's working on, sorry, not HTTPS, make sure it's HTTP only, localhost 8545, that's where it's running, right, your Anvil, and broadcast, and then you can also add private key there. So you can say private key is equal to the one that you just set, so that's private underscore key. Okay, something has gone wrong. Something seems off here, guys. Just a second. It's forward script slash crowdfunding.s.sol. fork URL broadcast. What if I remove this and don't pass anything here? Sounds weird. Let me inspect this. Yeah, so there were two issues with it. First, I realized that we had not run forge build, right? So you gotta run that. I've done that already. So my contract has been deployed. As you can see here, contract created. Right, contract was created. This is what you want in the Anvil tab. So for that, you want to first run forge build, right? And then let me show you. You'll also have to change your script. So the script name should be, which again I had not done, should be crowdfunding.s.sol. Once you do these two things, and once you run that same command again, the one which had for script, all of that, right, with the private key, it'll perfectly work. And in your Anvil, you'll see something like this, contract created. Okay, and this is the address that you want, because we'll be able to play with this now. All right. So yeah, there's a lot of steps in this project. Yes, I know, and some you can get confused a little bit here and there, but that's all right. At least we got it deployed, right? Now what we'll do is we'll define a couple of variables, and we'll actually create a campaign. So we'll say export contract address, right? And we'll set this. The contract address in my case is this one, which I have received. I will set it here, and then I will export the campaign owner. So in our smart contract, you know that there's a campaign owner that's required, the guy who can who starts the campaign and who can also withdraw the funds when the timeline runs out, right? So campaign owner private key, and we've already used the 0th private key, right? So we can use the first private key here from here. I'll set it equal to this. Okay. So campaign owner private key, and or just say priv key, because that's the one we'll be using later on. Say priv. Just keep things simple. Campaign owner priv key. Okay, and equal to this. Awesome. And then you'll export the campaign owner address. So that will be the first address that you'll get from here. So corresponding to the private key. And I'll set that also. And then there will be a donor. So there will be obviously multiple donors, but let's test for one donor. So one donor could be campaign donor. And then you have private key equal to, come again here, take the second private key from here, copy and paste it here, and you've set all these variables, right? Now there's a command for which I will put in the README file of the GitHub project. This is quite a big command, and you need to use the campaign owner private key here to start off the campaign. And we are saying we're using cast to interact with the smart contract that's deployed on the Anvil blockchain, right? And we use the contract address, which we have set, and only thing is contract address that we've set has double D, so I'll just say double D here. It's double D, capital D. Okay, create campaign. And to create campaign, you'll pass in the address, the string, and then you have these multiple string, right? All of these different things based on the campaign, based on your campaign, right? You have this address and then string, unt, all of those things, which you're passing to the create campaign function, like the owner, title, description, all of those things. So you have those things, and then you'll be using the campaign owner address that we just set here, campaign owner address, right? We're using that, and then we're calling it campaign 1, campaign owner description, and 10 ether. Now this part, right? The epoch time, we have to now replace. So we want to put in a time which is in the future, right? So let's take the current epoch time. So right now the epoch time is, sorry, this is the epoch timestamp right now. So you just go to epochconverter.com. Let me show it to you. So just go to epochconverter.com and you get the current Unix epoch timestamp. That's the one you need. Okay, and that's the one I put here, and I put 300 to it, 300 seconds. And now when we run this command, it should create the campaign for us. So it creates the campaign for you basically in the by interacting with the smart contract. Okay. Now, what if you want to get the campaign? So you remember you have a get campaign function, right? I'll show you. Now you call the create campaign function using cast. So you remember that there's Anvil, which helps you to deploy, which is a blockchain. Cast helps you to interact with the smart contract, and you call the create campaign function. Now you're going to call the get campaign function. So how you do that? So you say cast call and contract address, which you have set the variable for, get campaign, and you have here uint 256, and here you'll have multiple things like the address, string, all of that. Okay, so address, string, uint, string, and then we'll pass here 0. Okay, so it's gotten us the campaign data, campaign 1 description, all of that. And now if you want to donate to the campaign, you can also do that. So we'll say cast send, right? So you have to call the exact function, which is the donate to campaign function. Let's say cast send with the contract address that you have set. Yeah, contract, because to be able to interact with the particular contract, you need the address for the contract. So that's why we set it as a environment variable in a terminal. Say donate to campaign. Say uint 256 0 minus value, pass 10 ether to it, and then you have your private key variable equal to campaign donor private key. Okay, so why does it require the campaign donor private key? Because obviously you need the address of the contract, and then you need the private key donor campaign donor private key, because you are donating to the campaign, donating 0 obviously, but still donating to the campaign. So donated to the campaign, that's awesome. Now we can call the get campaign function again. So I'll say cast call get campaign function. Okay, and we can see right, so that's changed. And now we can let's see the balance. Sorry, cast balance. Let's see the balance of the campaign owner address right now. Sorry, balance BALANCE. So this is the balance right now of the campaign owner address, the guy who started the campaign. Now you want to withdraw, right? So you want to use the withdraw function to withdraw the balance. So we'll say cast send contract underscore address withdraw uint 256 0 minus private underscore key is equal to campaign owner private key. Something seems wrong here. Yeah, so it should be private dash key. Okay, okay, yeah. So the spelling of uint is wrong. Okay, so this is, you have withdrawn the balance. And now let's look at the balance again of that same guy. And now the balance has changed, right? You've removed the balance from that guy and the balance has changed. Right? Now let's deploy to Goerli. Let us deploy to Goerli now. So first you need export Goerli URL, and the URL that you got from Alchemy. So I'll use mine here. Just make sure it has Goerli in it. In the sense, it's not, you're not deploying to the mainnet. That'll be problematic. So you have the Goerli link that you got from Alchemy set up. Then you want to export your private underscore key. Should be equal to the private key that you got from MetaMask. Okay, so I'll set that. Then you want to set your Etherscan key. Your Etherscan key, so your Etherscan API. I'll change all of these things, by the way, after the video. And you will now deploy to the Goerli testnet. So you'll say forge create RPC URL, and you set that as the Goerli URL. And then your private key, or private key, /crowd funding.sol crowd funding, and then Etherscan API key, Etherscan underscore key, and verify. So use Etherscan to verify your Etherscan key and your private key that you just set from your MetaMask, and then your Goerli URL, right? All of these things required, and we'll run this command for forge, and it will send it to the Goerli testnet. Whew. Hopefully. So it's just deployed on Goerli. Awesome. Submitting verification now. Right, so you've started getting some data from Alchemy. So it's been deployed, everything works fine, right? It's just submitting verification for Etherscan. That'll take some time more. But yeah, what we wanted has happened. It's deployed on the Goerli testnet and everything works perfectly fine, blah, 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 blah. All right, so this is the project, this is everything. We've deployed to Goerli. So we started with I'll just go over it, everything quickly. So we started with an empty project, and we replaced the SRC folder with the new smart contract, which is crowdfunding smart contract. And the campaign owner can extract value with the help of withdraw function, and other people can donate to the campaign. And then you had a create new campaign function, which initiates the campaign. Okay, then you had a test file that you will copy from my GitHub. You have a script, you will again copy this from my GitHub. And then I'll leave all the commands also in my GitHub. I'm Akhil Sharma 90, and you'll be able to copy all of this stuff. And then we created a remappings for the issues to go away. Then we built our Forge function, we tested it, and then we deployed to Anvil. We interacted using cast with all the functions like the the create campaign function and the get campaign, get balance, all of those. And then we deployed finally to the Goerli test network. Okay. So all the steps are completed. And this is it. So I hope you learned a lot in today's video. And thanks a lot for watching. And I'll keep coming up with awesome content like this. Share it with your friends, right? Web3 is the future, according to me. And what you've learned today is very, very useful. You've learned how to work with Alchemy or Infura, right? Instead of Alchemy, you could just use Infura key. You learned how to work with, like, get the Etherscan API key. You learned how to, give yourself some Goerli using the testnet, faucet. So a lot of things, right? Most importantly, you learned about Foundry. Learn a lot more about Foundry, like many commands with Forge, Cast, and Anvil, all of these, right? So you just learned so much more about Foundry. And you built a smart contract from scratch. So that's a lot of stuff. So thanks a lot for watching, guys. We will meet in the next video.